ሰላም ጤና ይስጥልን የቻናሌ ተከታታዮች እንደምን አላችሁልኝ ዛሬ እንግዲህ ይዤላችሁ የቀረብኩት ሜካኒካል ቫይብሬሽን ሲስተም ነው በሁለት ነጥቦች ዙሪያ ላይ ነው የምናስስ የመጀመሪያው ነጥብ ምንድነው ወይም ፓርት 1 የምንለው መልቲ ዲግሪ ኦፍ ፍሪደም ሲስተም ሲሆን ሁለተኛው ክፍል ደግሞ ቫይብሬሽን ኮንትሮል ሜካኒዝሞች ላይ ነው ማለት ነው እንግዲህ ውድ ተመልካቾቼ በመጀመሪያ ሰብስክራይብ በማድረግ ጀምሩልኝ ከዛ ላይክ ሼር እና ኮሜንት ማድረጋችሁንም እንዳትረሱ የዶል ምልክቷንም ደግሞ ክሊክ አድርጓት ምክንያቱም የተለያዩ ቪዲዮዎችን በመጭንበት ጊዜ ኖቲፊኬሽን እንዲደርሳችሁ ያኔ የምትፈልጉትን ታያላችሁ ማትፈልጉትን ደግሞ መተው ስለምትችሉ ማለት ነው ወደፊት ያው እንግዲህ ብዙ ጀነራል ዕውቀቶችን ያተኮሩ ቪዲዮዎችን ለመስራት ዝግጁ ነኝ እንግዲህ የመጀመሪያው ክፍል መልቲ ዲግሪ ኦፍ ፍሪደም ሲስተም ይላል ወደ ስራችን ስንመለስ ይህ ሲስተም ምን ኮንቴንቶችን ይዟል ብለን ስንመለከት የመጀመሪያው ኮንቴንት መልቲ ዲግሪ ኦፍ ፍሪደም ሲስተም የሚል ነው ወይም what mean multi degree of freedom system የሚለውን እናስስበታለን ማለት ነው ሁለተኛው ላይ ከመልቲ ዲግሪ ኦፍ ፍሪደም ሲስተም ውስጥ አንዱን ነጥለን ወይም አንዱን ክፍል እንወስዳለን ማለት ያ ማለት 2 ዲግሪ ኦፍ ፍሪደም ሲስተም የሚለውን ለምሳሌ that means በነገራችን ላይ 2 ዲግሪ ኦፍ ፍሪደም ሲስተም ብቻ ሳይሆን 3 ዲግሪ ኦፍ ፍሪደም ሲስተም 4 ዲግሪ ኦፍ ፍሪደም ሲስተም እያለ ይቀጥላል ግን ከነዚህ መካከል አንዱን 2 ዲግሪ ኦፍ ፍሪደም ሲስተም የሚለውን እንወስዳለን ማለት ነው በሶስተኛ ደረጃ የምንመለከተው ነጥብ ቢኖር summarized formulas on 2 degree of freedom system ነው እንግዲህ summarized የሆኑ ፎርሙላዎችን በ2 degree of freedom system ላይ እናያለን ማለት ነው በነገራችን ላይ ሃይላይት ነው ያሳያችሁ ያለ ሃይላይት ነው ዲቴል አይደለም ግን ቤዚክ የሆኑ ነገሮችን ሃይላይት ነገሮች ነው ማለት ነው በአራተኛ ደረጃ የምንመለከተው 2 degree of freedem system coordinate coupling መቼ ነው coupled የምንለው ወይም ደግሞ uncoupled የምንለው መቼ ነው ይ 2 degree of freedom system ሌሎችም 3 degree of freedom system ሊሆን ይችላል እያለ ይቀጥላል ግን coupled የምንለው መቼ ነው የሚለውን እንመለከታለን ከዛ በመጨረሻ ደረጃ ላይ n degree of freedom system የሚለውን ጀነራል ፎርሙላዎችና ጀነራል ኢኩዌሽኖች አውጥተን በዚህ እናጠቃልላለን የፓርት 1ን ማለት ነው n degree of freedom system ማለት ኦሬዲ መልቲ ዲግሪ ኦፍ ፍሪደም ሲስተም ሊሆን ይችላል n1 ከሆነ ሲንግል ዲግሪ ኦፍ ፍሪደም ሲስተም ይሆናል n2 ከሆነ 2 ዲግሪ ኦፍ ፍሪደም ሲስተም 3 ከሆነ 3 ዲግሪ ኦፍ ፍሪደም ሲስተም እያለ ይቀጥላል ነገር ግን n ዲግሪ ኦፍ ፍሪደም ሲስተም ብለን ግን ጀነራል ኢኩዌሽን ማውጣት እንችላለን ለዛም እንመለከታለን ማለት ነው ወደፊት ኮንቴንቱን ይመስላል ይሄን ካየን what mean multi degree of freedom system የሚለውን እንመለከታለን what mean multi degree of freedom system if the system requires more than one independent coordinate to describe its motion or to specify the position of the particles it is called multi degree of freedom system or an n degree of freedom system where n is the number of coordinates required for example let's say x1 x2 x3 x4 coordinates maybe exist so based on the number of these coordinates we can decide either multi degree of freedom system or single degree of freedom system either 2 degree of freedom system or 3 degree of freedom system but this is depending on the independent coordinates so if the independent coordinates or the variables are what more than one these are the multi degree of freedom system multi degree of freedom system multi degree of freedom system example let's see some examples for example 2 degree of freedom system is what one part of multi degree of freedom system and 3 degree of freedom system is one part of multi degree of freedom system 4 degree of freedom system is another part of multi degree of freedom system so let's see the 2 degree of freedom system for example here there is a fixed part here and this is free from the right side but it has what m1 and m2 two masses and 2 springs so due to this one spring and one mass we have what one degree of freedom system, and due to this mass and this spring we have another 1 degree of freedom system. So thus 1 degree of freedom systems are in the combination, thus gives what 2 degree of freedom system. And also the next, because of even we have what x1 and x2 coordinates, so due to x1 and x2 coordinates it is possible to decide this is 2 degree of freedom system. And for this one, for the other one, here we have x2 and here x1. So this mass had what 2 directions, in the left direction or in up and down. It can what move horizontally and up and down. So we have what 2 coordinates, or we have 2 independent variables or independent coordinates. So due to this independent variables we have what 2 degree of freedom system. So this system is 2 degree of freedom system. And the third one, here also we have what m1 and here k and k theta, because there's a torsion also, there is a twist. So due to that there is a twist angle. Due to this twist angle or due to this independent coordinate we have 1 degree of freedom system, and also due to what the x up and down we have another degree of freedom system. So this had what 2 degree of freedom system አለው ማለት ነው። ስለዚህ ስንመለከተው እዚህ ጋር ምንድነው ማስዋን አለን ማስተዋለን k1 እና k2 ስቲፍነሶች አሉን። እንደገና ቫሪያብሎች ኢንዲፔንደንት ቫሪያብል የምንላቸው x1 እና x2 አሉኝ። ስለዚህ በእነዚህ x1 እና x2 አማካኝነት ሞሽኑ ሁለት ሞሽኖች ስላሉት በዛ አማካኝነት 2 degree of freedom system ማለት ይቻላል። ይሄኛው ደግሞ ሆሪዞንታሊ መንቀሳቀስ ይችላል፣ እንደገና አፕ ኤንድ ዳውን መንቀሳቀስ ይችላል። ስለዚህ 2 degree of freedom system ነው። ይሄኛውም አፕ ኤንድ ዳውን መንቀሳቀስ ይችላል፣ እንደገና ደግሞ መጠማዘዝ ይችላል። በመጠማዘዝ የሚያገኙ ቴታ አንግል አለ። ሶ በዚህ አማካኝነት 2 degree of freedom system እንለዋለን ማለት ነው። እነዚህም ይሄ ተመሳሳይ ናቸው የላይኛውና ይሄኛው። ግን ቢን ስንመለከት this is already what the shaft, and here it is assembled with what a pulley. So due to this pulley we have theta 2, and due to this pulley we have theta 1. So due to theta 1 it is 1 degree of freedom system, and due to theta 2 it has also what another degree of freedom system. So when we take the both systems it is what 2 degree of freedom system ይሆናል ማለት ነው። በሁለቱ አማካኝነት ይሄኛውን ብናቆመው በዚህኛው ትዊስት ማድረግ እንችላለን፣ በዚህኛው ትተን ይሄኛውን ትዊስት ማድረግ እንችላለን። 2 degree of freedom system አለው ማለት ነው። and the last one ስንመለከት ወደ ሆሪዞንታሊ ሙቭ ማድረግ ይችላል due to spring and mass. here mass አለ spring, and here then due to pendulum ደግሞ due to this theta ደግሞ በፔንዱለም መወዛወዝ ይችላል ማለት ነው። ስለዚህ ሁለት ሞሽኖች አሉት ማለት ነው። ይሄኛው አንድ አለኝ theta 1 variable, and here also x1 variable አለኝ. so due to those 2 independent coordinates this is 2 degree of freedom system ነው ማለት ነው። 3 what about the 3 degree of freedom system? 3 degree of freedom system, for example here we have at c and k, that means damper coefficient, here also what stiffness coefficient, and here what m1. so using this only this system we have one single degree of freedom system. And also when we take the m2 here and this k2 spring we have what spring mass system, so this is another single degree of freedom system. And also when we take the m3 we have what damper and 2 parallel springs, so 2 parallel spring with this damper we have what another single degree of freedom system. But when we combine this all the single degree of freedom system as one system it is what 3 degree of freedom system ይሰጠናል ማለት ነው። እዚህ ጋር ለብቻው single degree of freedom single degree of freedom single degree of freedom ስለምናወጣለት በአጠቃላይ 3 degree of freedom system ማድረግ ይቻላል ሲስተሙ ማለት ነው፣ ሙሉ ሲስተሙ። here also እዚህ ጋር ስንመለከት ይሄኛው ስፕሪንግ አለ m1 ነው፣ ይሄኛው ስፕሪንግ አለ m2 ነው። ይሄ ለብቻው ከላይ ያለው ፓርት ለምሳሌ ይሄ ከዚህኛው ጋር አንድ ሲንግል ዲግሪ ኦፍ ፍሪደም ሲስተም ነው፣ ይሄኛው ከዚህኛው ጋር አንድ ሲንግል ዲግሪ ኦፍ ፍሪደም ሲስተም ነው because of the independent coordinate x2 ስላለች፣ እዚህኛውም independent coordinate x1 ስላለች። ስለዚህ 2 ዲግሪ ኦፍ ፍሪደም ሲስተም ሆነ። ይሄኛው ደግሞ 3 1 አናዘር ቴታ 3 ያለን ማለት ነው። እዚህኛውም ቴታ 4 ይኖረናል ዲዩ ቱ ዘስ M3 and M4 ፔንዱለምስ ሶ በነዛ አማካኝነት 4 ዲግሪ ኦፍ ፍሪደም ሲስተም ይኖራል ማለት ነው። በት ኢንፋይናይት ዲግሪ ኦፍ ፍሪደም ሲስተም የሚለውን ስንመለከተው እዚህ ጋር ይሄ ስፕሪንግ ኤንድ ዳምፐር ኤንድ ማስ ስፕሪንግ ዳምፐር ኤንድ ማስ spring and damper and mass it's up to a spring and damper and mass m እስከ n ድረስና k ደግሞ n plus 1 ድረስ ይሄዳል ማለት ነው n plus 1 because there is what extra 1k ስለሚኖር because of this is fixed ስለሆነ fixed ባይሆን ኖሮ ግን የኛው ፓርት አይኖርም እዚህኛው ያለው ብቻ ይሆን ነበር ማለት ነው ስለዚህ ፊክስድ ስለሆነ የኛው ክፍል ለብቻው kn + 1 ድረስ ይሄዳል so this is infinite ነው or n number of degree of freedom system ነው ስለዚህ n ን ዲተርማይን እናደርጋለን n ድረስ ከሄደ ማለት ነው let's see the 2 degree of freedom system this is the part of what multi degree of freedom system so free vibration analysis of an undamped system that means there isn't what a damper so we don't care about the damping conditions so this is only the mass spring system here let's see this example here there is a spring here mass here a spring here mass and spring and fixed from both sides and also due to this friction there is a mass there is inertia force so for this system for example when we see this part m and k we have a single degree of freedom system and for the second one to m and k with this k this both k this is another single degree of freedom system because we have what x2 independent coordinate for this also we have x1 independent coordinate so due to this is what 2 degree of freedom system so we have to find what or we have to draw the free body diagram to write the equation of motion so when we see this is the motion is what towards the right the motion is towards the right so due to this for example let's see this part m is moving towards the left the right so due to this the spring will apply what the tensile load on m1 that means the resistance force will be what towards the left and also for this one because of this mass is going to what the right this spring will be compressed if the second mass is stopped at this point and also for that means the spring force will be what towards the left like this towards the left this also towards the left here also towards the left and when we see the 2m this 2m is going to what the right so due to that this spring will be compressed and this spring will be what stretched that means due to this one this is compressed ሲሆን ወደዚህኛው ወደ ሴንተሩ ይገፋል ማለት ነው ይሄኛው ደግሞ stretched ሲሆን ወደዚህኛው ይሳባል ማለት ነው ይሄኛው stretched ሲሆን ይሄኛው ወደዚህ በሚሄድበት ሰዓት ይሄኛው compressed ሲሆን ይሄኛው compression force apply ያደርጋል ይሄኛው ደግሞ በዚህኛው አማካኝነት ሲገፋና ይሄ ወደዚህ ሲመጣ ይሄ ፎርስ አፕላይ የሚሆነው ወደ center of what the mass ይሆናል ማለት ነው center of the mass because there is a force from m1 there is a force from m1 the m1 is like a force this m1 is pushing this spring and this spring also push this one and this also push this one so the spring force will be what towards the center of 2m እዚህ ጋር ምንድነው የምንመለከተው? ይሄ ስፕሪንግ አለ፣ ማስ አለ፣ ስፕሪንግ አለ፣ ማስ አለ። ስለዚህ K1 ነው ዘሴም ስፕሪንጎች ስለሆኑ ነው። ስለዚህ የነዚህን ስንመለከት ይሄ ወደ ቀኝ ስለሆነ ሁሎች ሙቭ የሚያደርጉት እዚህኛው ላይ ቴንሳይል ነው የሚፈጠር። ስለዚህ towards the left ነው ማለት ነው አፕላይ የሚያደርግ ስፕሪንጉ። ለዚህኛው ግን ስለሚጫነው ኮምፕሬሽን ስለሆነ towards the left አሁንም አፕላይ ያደርግበታል ወይም ወደ ቦዲው አፕላይ ያደርጋል ማለት ነው። ይሄኛውን ስንመለከት ይሄ ወደዛ ነው የሚሄድ። ወደዛ ሲሄድ ለዚህኛው ኮምፕረስድ ነው የሚያደርገው። ያ ማለት ይሄ ስፕሪንግ ወደ ቦዲው ነው የሚጋፋ ወይም ወደ ቦዲው ይጋፋል። እንደገና እዚህኛው ስንመጣ ደግሞ በዚህኛው ማስ አማካኝነት ይሄ ስፕሪንግ ስለሚጫነው ይሄንን ማስ ይጫነዋል ማለት ነው። ያ ማለት ፎርሱን ወደዚህ ይገፋዋል ማለት ነው። ሶ ኢኩዌሽን ኦፍ ሞሽኑን እናውጣ። ኢኩዌሽን ኦፍ ሞሽኑን ስንመለከት ለምሳሌ ወደ ቀኝ የሚሄዱትን ፖዚቲቭ ኤንድ ወደ ግራ የሚሄዱትን ደግሞ ኔጌቲቭ ማለት ይቻላል። ለምሳሌ kx1 is negative, that means minus kx1, and here also k into x1 minus x2 ምንለው ኔጌቲቭ minus kx1 minus x2 ኔጌቲቭ which is equal to mx1 dot dot this also ኔጌቲቭ ነበረ ግን ወደዚህ ስላሻገር ነው ከእኩል ይሆናል ወደዚህ ስላሻገር ነው ፖዚቲቭ አድርገነዋል ማለት ነው። ለሁለተኛውም ለዚህኛው ፓርት የምንመለከት ይሄኛው ወደዚህ ስለሆነ ፖዚቲቭ ነው፣ ይሄ ወደዚህ ስለሆነ ኔጌቲቭ ነው የሚመጣ kx1 minus x2 positive because this is towards the right, and minus kx2 negative because this is what towards the left, which is equal to mx2 dot dot. mx2 dot dot is what negative, but when we ይሄንን ወደ ቀኝ ስናስቀምጠው ግን ምን ይሆናል ማለት ነው? ፖዚቲቭ ይሆናል ማለት ነው። in matrix form ስንመለከት ኢኩዌሽን ኦፍ ሞሽንን in matrix form እንመለከተው። for example ለመጀመሪያው ማስን ስናወጣ m አለ፣ x1 ዶት ዶት አለ፣ x2 ዶት ዶት is empty ነው እንዲህ ሮ ማለት ነው። x2 ዶት ዶት ከሌለ m1 ለx1 ዶት ዶት ብቻ እዚህ ጋር እናስቀምጣለን። እዚህ ጋር የሚቀመጠው ክፍል ግን 0 ይሆናል ማለት because there isn't x2 ዶት ዶት. for the second equation also mx2 ዶት ዶት አለ፣ x2 ዶት ዶት አለኝ ግን x1 ዶት ዶት የለኝም። that means x1 ዶት ዶት እዚህ ጋር ነበር የሚሆን የለኝም 0 አደርጋለሁ to m ይኖረኛል ለx2 ዶት ዶት ማለት ነው። ፕላስ ለዚህኛውም ለk እና ለkም ለዚህኛውም ልክ በዛው ልክ to k minus k ይመጣል። that means x1 እና x2 ስላለኝ እዚህ ጋር ለx1 ምን አለኝ to k አለኝ ለx2 minus k አለኝ እዚህኛው ጋር። እንደገና ደግሞ ሁለተኛ ኢኩዌሽን ላይ ደግሞ ለx1 minus k አለኝ ለx2 ደግሞ to k አለኝ ማለት ነው። x1 x2 which is equal to 0 0 because we haven't the force. Two degree of freedom system, we have the general equation of motion for this matrix form. The general equation of motion seems like this one. This is the general masses. Here also the damper coefficients. Here also what the stiffness coefficient. That means mx dot dot of t, which is the inertial force, plus cx dot due to the damping plus the damping force plus kx. This is what the spring or restoring force, which is equal to f of t. If f is 0, which is equal to 0. M is the inertia of mass matrix, c is the damping matrix, and k is the stiffness matrix, f is the external force vector, and x is the position vector, n times 1. Here the initial conditions. After we calculate or we find the different equations, we have to apply the initial conditions to find different constants. Two coupled or second order ordinary differential equations with constant coefficients. This is needed for constants of integration to solve for 2 degree of freedom system, and thus for initial conditions on position and velocities. That means to find the velocity, to find the other constants, or to find what the general solution, we have to do what the initial conditions. For example, x1 of naught is equal to x1 of naught, x1 dot of naught is equal to x1 dot of naught, x2 0 which is equal to x2, x2 derivative which is equal to x2 derivation at initial condition. In matrix form also seems like what? This is with initial condition x of naught, x1 of 0, x2 of 0, x dot ስንል ደግሞ x dot 1 of 0 እና x dot 2 of 0 አለን because this is two equation of motion ስላለው ማለት ነው። initial conditions የሚለው እነዚህን ፎርሙላዎች ይጠቀማል። አሁን እነዚህ ፎርሙላዎች የሚመጡ ምንድነው ሞድ ሼፕ and the natural frequency ከፈለግን በኋላ ሞድ ሼፖችን ከፈለግን በኋላ ጀነራል ኢኩዌሽን እናመጣለን። ይሄን ጀነራል ኢኩዌሽን ካመጣን በኋላ ኢኒሻል ኮንዲሽንስ ጊቭን ካለን የሚሰጠን ኢኒሻል ኮንዲሽን ተጠቅመን ወደ ጀነራል ፎርሙላው አስገብተን ውጤቶችን እናገኛለን ማለት ነው። እዚህ ጋር የምንፈልጋቸው እንግዲህ ሞድ ሼፕ ከፈለግን እና እንደገና ደግሞ ፍሪኩዌንሲ ከፈለግን ከዚህ በኋላ at initial condition ላይ ያስገባን that means at x1 of 0 2 ላይ x2 of 0 4 or x1 dot of 0 0 x2 dot of 0 0 ያስገባን ከዚህ ጋር የቫልዩ ኦፍ phi1 እና የቫልዩ ኦፍ c1 እናገኛለን ማለት ነው። value of c1 and value of phi1 ዘን እነዚህን ቫልዩዎች ካገኘን በኋላ እንግዲህ ምንድነው የሚሆን ጀነራሊ ሰብስቲቲዩት አድርገነው ቶታል ፉል የሆነ ኢኩዌሽን ይኖረናል ማለት ነው። then after that ሶሉሽናችንን በዛ መልኩ ማስቀመጥ እንችላለን። summarized formulas on 2 degree of freedom system. The first one, as we see, this is equation of motion. That means mx dot dot of t plus kx of t which is equal to 0. This is the general equation of motion for undamped free vibration. The motion is synchronous. That means we have a constant angular frequency and what? The constant phase angle. X which is equal to a sine omega t plus phi, or ae the power of j omega t plus phi. This is a synchronous equation. An eigenvalue problem. This is also the eigenvalue problems. To find the eigenvalue, we have to use these formulas. That means k which is equal to minus omega square m into x of t which is equal to 0. But when we divided this part by x of t and this part by x of t, we will get what? The determinant k minus omega square m which is equal to 0. Omega n square eigenvalue and omega 1, omega 2, omega 3 up to omega n there may be exist in the system if it has what? It has n degree of freedom system. n degree of freedom system ሲኖረው ኦሜጋውም n ድረስ ይሆናል ማለት ነው። and ሞድ ሼፖችም n ድረስ ለምሳሌ 3 degree of freedom system ከሆነ 3 ኦሜጋዎች ይኖሩናል፣ 3 ሞድ ሼፖች ይኖሩናል ማለት ነው። እነዚህን ፎርሙላዎች እንጠቀማለን። and also free undamped response. For free undamped response, the general formula will be what? Like this: x1 a1 sine omega 1t plus phi 1 plus x2 a2 sine omega 2t plus phi 2 plus xn an sine omega nt plus phi n. Then this is the general equation x of t in the summation from I which is equal to 1 up to n xi ai sine omega nt plus phi 1 phi I. This means the general formula. Then you can what? in በመበታተን መጠቀም ትችላላችሁ where a and phi are from initial conditions የምናገኛቸው ናቸው ማለት ነው። I እና phi እና ai የምንላቸው ከኢኒሻል ኮንዲሽን የሚገኙት ናቸው። So two degree of freedom system coordinate coupling የምንለውስ ምንድነው ነው? The differential equation of motion for the two degree of freedom system are in general coupled ነው when both coordinates appear in each equation. For example እዚህ ጋር ስንመለከተው m x1 አለ m x2 አለ m k x1 እና k x2 አለ x1 እና x2 የምንለው ሁለቶችም በአንዱ ኢኩዌሽን ላይ የሚገኙ ከሆነ coupled ነው ማለት ነው or እዚህኛው ሁለተኛው ኢኩዌሽን ላይ ሁለቶችም x1 እና x2 የምንላቸው በዚህ ኢኩዌሽን ላይ የሚገኙ ከሆነ በዚህና በዚህ የሚገኙ ከሆነ coupled ናቸው that means it is impossible to find the solution individually or using only one equation using only one for this formula በመጠቀም ብቻው ማግኘት አንችልም ይሄኛውም ኢኩዌሽን አስፈላጊ ይሆናል ማለት ነው ስለዚህ coupled ነው የምንለው in matrix form ስናስቀምጠው it will be at the following for example m11 m12 m21 m22 into x1 dot dot x2 dot dot plus k11 k12 and k21 k22 in the x1 and x2 is equal to 0 so from this one ለምሳሌ m12 እና m21 0 ቢሆኑ or diagonally the same ከሆኑ coupled አይደለም ማለት ነው ምክንያቱም ለብቻው መሰራት የሚችል ነው የሚሆነው እዚህ ኢኩዌሽኑ ሲመጣ x2 አይኖርም ማለት ነው ግን ይሄኛውና ይሄኛው diagonal ካልሆኑ ወይም ደግሞ 0 ካልሆኑና እኩል ካልሆኑ ይሄ ምን ይሆናል ማለት coupled ይሆናል ምክንያቱም ሁለቱን ኢኩዌሽን መጠቀም መቻል አለብን ማለት ነው k11 k12 እንደዛው እነዚህ ሁለቱ ዲያጎናሎቹ the same ካልሆኑና 0 ካልሆኑ በስተቀር or diagonal ካልሆኑ በስተቀር ኢኩዌሽኑ coupled ይሆናል ማለት ነው ለዚህ ለብቻው coupled ሊሆን ይችላል ለማስ ብቻ coupled ሊሆን ይችላል or ለሁለቱም coupled ሊሆን ይችላል ማለት ነው ማስ ሲሆን mass or dynamical coupling exists if the mass matrix is non-diagonal mass matrix ይሄ mass matrix የምንለው እዚህ ጋር non-diagonal ከሆነ coupled ነው የምንለው because it is impossible to solve the problem by using what only one row and row-ን በመጠቀም ብቻ መፍታት ስለማንችል x1 x2 plus c11 for example ለዚህኛው ስንመለከት k11 k22ን ስንመለከት አሁን coupled አይደለም uncoupled ነው because ለብቻቸው መፈታት ይችላሉ ይሄኛውን ግን ስንመለከት c ላይ ስንመለከት c11 c12 c21 c22 አናውቅም c12 እና c22 diagonal ካልሆኑ coupled ይሆናል diagonal ከሆኑ ብቻ ነው coupled ማይሆን ማለት ነው the system that has zero dynamic and static coupling but the coordinates are coupled by the damping matrix if c12 is equal to c21 is equal to 0 the system equation becomes what uncoupled let's see any degree of freedom system this any degree of freedom system may include what 2 degree of freedom system 4 3 5 we don't know but there is any degree of freedom system the equation of general any degree of freedom system can be derived using what Newton's second law of motion the general form for example here we have what mi xi dot dot which is equal to summation of fij for mass mi or for what the rigid body of inertia ji theta I dot dot is equal to summation of mij the response of spring mass damper any degree of freedom system for example let's see this one this system had what n masses n number of masses that means m1 m2 up to mn and there is what a stiffness up to kn plus 1 and the damping coefficient up to sc n plus 1 so this is a multi degree of freedom system or any degree of freedom system for this multi degree of freedom system or any degree of freedom system using the application of Newton's second law of motion to mass mi we can find what the free body diagram and the equation of motion the free body diagram for example it seems like this one mi there is a mass but for this mass there are what a tensile forces from both sides. For example, let's see this part. For example, let's take M2 or MI or something. Let's say MI. So for this MI, we have what? This spring and this spring. This spring and this spring applies what? The tensile force for MI. The tensile force for MI. Because this is stationary, so due to the other mass spring systems, it will what? Move to and fro. So here, because of this, these are what? The tensile forces towards the left and towards the right. This is a general free body diagram for this multi-degree of freedom system. And the other one is, we have to find what the equation of motion from this free body diagram. That means, for example, for a stiffness, Ki xi minus towards, that means towards the left is what? Negative, and towards the right is positive. So due to that, Ki xi minus xi minus 1 is negative, and Ki plus 1 into xi plus 1 minus xi is positive from here. And for the damping also, this is negative, and here also what? This is positive, and the mass is also what? Negative. Then the general formula will be like this. The general formula will be like this. That means I is starting from 2, 3, 4 up to n minus 1. And the equation of motion, generally we can what? Collect like this. That means that the similar terms will be what? Collected into one place, and then we can write the equation again. So this is already the same, but the only difference is what? Collecting the like terms. Collecting the same or like terms. And the equation of motion of the mass m1 and mn can be derived from the above equation by setting I is equal to 1 along with x naught is equal to 0 and I is equal to n along with xn plus 1 is equal to 0 respectively. That means, for example, the first one, when we see the first one, that means when I is equal to 0, we have the equation from this part, m1 x1 dot dot plus c1 plus c2 into x1 dot minus c2 x2 dot plus k1 plus k2 into x1 minus k2 x2 is equal to f1. But when we apply what? The I is equal to n, we have what? This one. We have this one. Then the equation of motion can be expressed in matrix form like mx dot dot plus cx dot plus kx, which is equal to f. This is a vector, or all are the vectors, but this is double dot, and here single dot, and here without dot. This is a general formula which is equal to force. This is a general formula for any degree of freedom system in matrix form. Now we can continue the part 2. The part 2. In the part 2, we have to discuss what about the vibration controls. If there is a vibration, how we can control this vibration. There are different methods. There are different mechanisms to control the vibration of the system. So in this case, we will include what some pointers. The first one is vibration control. What means vibration control? And the second one is about what the vibration isolation. This is one mechanism of vibration control, and the other one is the vibration absorber, and then the redesign of the system. these are the basic important parts. So what mean vibration control? There are several techniques can be used to reduce and eliminate the shock and vibration response of mechanical systems and structures. From this systems or from this mechanical systems, we can use some strategies to reduce the vibration, problems. Some strategies are included like the control of excitation. This is external force, the control of external force, or the control of external vibration force, which comes from the sources. For example, like the balancing of machine. And the second one, vibration isolation. This is a reduction of what forces transmission to the machine by using some isolators. We have to reduce what the source or the transmission of the forces from one part to the other part, because there is isolation in the middle part of what the two systems. And the vibration control absorber system, that means vibration absorber. This is a very interesting and important which controls of the system configuration. For example, change of system order with a vibration absorber. That means we will add some other vibration absorbers. Then from that means, for example, there may some system, and if there is a problem of vibration, we will add another vibration absorber. That may be the same thing, the same material or the same system, but that must reduce the vibration of the first system. System redesign. This is a very important to control of a system parameters. For example, like the mass, like the damping system and the stiffness. To control of these parameters, we will redesign the system and reduce the vibration of the total system. Change of system parameters. Let's see the vibration isolation. When we see the vibration isolation, this vibration isolation is the process of isolating an object such as a piece of equipment from the source of vibration. That means already reducing the force of the vibration which comes from the source, and to transmit to the other machine elements. The control is analyzed in terms of reducing the vibration, displacement transmitted through the base motion, or in terms of reducing the force transmitted by the source through its mounting point. But this vibration isolation is divided into two. The first one is the passive vibration, and the second one is active vibration isolation system. What mean passive vibration isolation system and active vibration isolation system? Passive vibration isolation makes use of materials and mechanical linkages that absorb and damp these mechanical waves. For example, from this figure, we have a spring and a damper here. So using this spring and damper, we will reduce the transmission of the forces between the mass and the ground part. So this uses the materials and mechanical linkages. This may be or another mechanical linkage, and that absorbs and dumps this mechanical wave, such as a shock mount. In general, contains mass, spring, and damping elements. Here, mass, spring, and damping elements are included for passive vibration isolation system, and moves as a harmonic oscillation. For example, for the second one here, we have K and C, but there is a force x of t is equal to x sine of omega and t minus phi. Vibration is a displacement. This is vibration absorber. Here this is the circled part is the vibration absorber, and we have what y of t is equal to y sine omega t. Here there is a force, excitation force. So due to this force, this mass maybe what vibrate, but to reduce that vibration we have to use the stiffness and what the dampers. And active vibration isolation, which involves what sensors. For example, the piezoelectric accelerometer or JOFO, a controller and an actuator. That means this system is what gives the feedback immediately when the vibration starts. Immediately. This is active already. That produces a destructive interference that cancel out what the incoming vibration. Cancel out the incoming. When that starts, this system cancel out that vibration immediately. For example, let's see this figure, the last figure, this one. Here there is what isolated payload. Here is spring and damper, and here also motion sensor. There is a sensor, and here filter, high voltage amplifier, and here piezoelectric transducer, then intermediate watt mass. Here there is a mass. So immediately when there is a force and when the vibration starts, this sensor will apply its action to control what? The vibration of the system. This is also like that. There is a sensor here, and here feedback then gives the information for the actuator, then the actuator immediately actuates and reduces the vibration of the system. Vibration absorber. What means vibration absorber? This is the second part. Vibration absorber protects a device from steady-state harmonic disturbance at constant frequency. In this case, the frequency is constant, and it is what? A steady-state harmonic motion. So the disturbance of this steady-state harmonic motion is controlled by using the vibration absorbers. It consists of a second mass spring combination or second mass spring damper combination added to the primary device to reduce what? Remove the vibration. That means we will add another mass spring system or another mass spring damper system to reduce what? The previous vibration. To reduce the previous vibration or to remove the vibration which occurred in the previous. For example, let's see here. Assume this is already stopped here, and a main mass here, F naught sine omega t here, and absorber is also what? Here. The first part is this one, only the blue part, main mass, and here we have F naught sine omega t, and here there is a spring. But because of the vibration problem, we have to what? Add another spring mass system to control the vibration. So this is for example, this is what? The equilibrium part. This is another part due to what? This external mass spring addition, and here also external mass spring addition, here also mass spring addition. But in this case and in this case, the springs and the masses are what? Totally, the both springs and both masses are totally what? In motion. Here also totally in motion, but the middle part is what? Only the last spring and masses move, because this is already in a stable condition due to this external mass and spring. እዚህ ጋር ምንድነው? ማስና ስፕሪንግ አለ። ማስና ስፕሪንጉን ስንጨምረው ሌላ ማስና ስፕሪንግ ስንጨምርበት የነበረውን ቫይብሬሽን እየቀነሰ ያስኬድና ኖርማል ይሆናል እሱ ብቻውን ሊወዛወዝ ይችላል ማለት ነው ብቻውን ይወዛወዛል ግን የነበረው የመጀመሪያ ለምሳሌ ይሄን ብንወስድ በጣም ይወዛወዛል እንዲህ የነበረውን ስንጨምርበት እየቀነሰው ይሄንን አመጣ ከዛ ሪዲዩስ ካደረገ በኋላ ቶታሊ ይሄኛው ላይኛው ፓርት ሊቆም ይችላል ታችኛው ሊወዛወዝ ይችላል ማለት ነው the motion absorbed amount depend on absorber mass ነው ዲፔንድ የሚሆነው for example እዚህኛው ጋር እንመለከት ታችኛው vibration absorber ላይ እዚህ ጋርም ስንመለከተው f sin omega t ያለ host m1 አለ ይሄ the same የነበረ ነው ግን ይሄን ቫይብሬት እያደረገ የሚያስቸግረን ከሆነ ሌላ አናዘር ማስ ስፕሪንግ ዳምፐር ሲስተም አድ እናደርግበትና ሪዲዩስ እናደርገዋለን ማለት ነው ሪዲዩስ እናደርገው this is vibration absorber what is system redesigns system redesign ምንድነው it is making changes by creating and adding new content to the structure and function of a vibration system so as to better serve the purpose of the original design or to serve purposes different from those set forth in the original design. It should focus both quantitative and qualitative needs. That means ይሄ ምንድነው የነበረ ሲስተም አለኝ የነበረውን ሲስተም ለማሻሻል በኳሊቲ የሚሆን በቁጥር ደረጃ ለማሻሻል እንደገና ቼንጅ እናደርጋለን ወይም ደግሞ የሆነ ሲስተም አድ እናደርግበታለን ማለት ነው ካልሆነ ፓራሜትሮችን ብቻ እንቀይርና ራሱን ሰርቪስ እንዲሰጠን በጥሩ ሁኔታ ራሱን ሰርቪስ እንዲሰጠን ልናደርግ እንችላለን ወይም ደግሞ ሌላ ፋንክሽን እንዲሰጠን ልናደርግ እንችላለን ማለት ነው ለምሳሌ making changes by creating and adding እዚጋ creating አለ and adding new content ሌላ ኮንቴንት አድ በማድረግ ወይም ክሬት በማድረግ ስትራክቸሩ ላይ ሲስተሙ የነበረውን ፐርፐዝ እንዲ አሻሽሎ እንዲሰጠን ወይም ደግሞ ሌላ አዲስ ፐርፐዝ ወይም አዲስ ስራ እንዲሰጠን እናደርጋለን ማለት ነው እና ፎከስ የሚያደርግ ኳሊቲ ላይ እና ኳንቲቲ ላይም ሊሆን ይችላል system redesigning some steps of redesigning processes አሉት the first one define vibration system process ነው vibration system process-ን first of all define ማድረግ አለብን and then analyze vibration system process and the defined vibration process must be what analyzed again and then identify which is the problem and analyze improvement opportunities and find the opportunities to what improve that and then design future state processes then we have to what start the design situation or the design condition እንጀምራለን ዲዛይን ማድረግ ላይ እንጀምራለን ከዛ develop future state change and implement future state change ነው that means vibration system process-ን define ይሄ እንደዚህ ስለሆነ ነው ብለን define እናደርጋለን and then analyze የምናደርገው vibration system process-ን ያንዳንዱ analyze አድርገን እንጠቀማለን then identify እናደርጋለን ማለት ነው identify ስናደርግ ምንድነው improvement opportunities ምንድናቸው የሚለውን identify እናደርጋለን ስለዚህ በምን መልኩ improve ማድረግ እንችላለን ከዛ በኋላ ያን ካወቅን በኋላ ወደ ዲዛይን ፊቸር ስቴት ፕሮሰስ እንገባለን ማለት ነው ዲዛይን እንጀምራለን ቀጥታ ከዲዛይን በኋላ ዴቨሎፕ ፊቸር ስቴቱን ዴቨሎፕ ማሳደግ ነው ከዛ ኢምፕሊሜንቴሽን ወይም ተግባር ላይ እናውለዋለን ማለት ነው